right, welcome everybody to Dave Cooper Live Monday Expert Interview. And today we are talking about multi-hazard precast concrete modular solutions. That's right. We're going to learn how Fortress protective buildings provide balanced protection for a full range of hazards, including blast, thermal, toxic gas, fragments, and extreme weather. These are turnkey precast concrete building solutions designed by Baker's Risk and manufactured by Tyndall, protecting the structures and the lives of those inside. Pretty pertinent for today. So, with that said, we are going to welcome Karen Vilas, the president of Fortress Protective Buildings. She has experience in technical process safety within the petrochemical industry. She's focused on hazard and risk management designed to protect people and critical infrastructure in high hazard environments. And unfortunately, that is the world we live in right now. And Karen has a permanent prefab solution for you. So this is going to be a fun show today. Something we haven't done on this show in the past, but it's very pertinent to where the world is heading at this very, very moment. But first, we got to thank all of our sponsors. So here's a quick shout out to them. Stream Modular, the only logistics company you need to transport your mods, pods, and panels. Our friends at Stream Modular are investing $50 million over the next 25 years to build the technology, solutions, and trailers needed to handle and transport the projects of today and meet the demands of tomorrow. Reach out to their team at streammodular.com to discuss your next project. CombiLift is the largest global manufacturer of multi-directional forklifts and straddle carriers, a leader in long load handling solutions, offering a free warehouse and site optimization design service. CombiLift helps companies of all sizes and from every industry maximize the capacity, safety, and efficiency of their warehouse and storage facilities. A big thank you to Paul Short and the team at CombiLift for helping us all to build it better. Visit them at combilift.com. Brave Control Solutions, where offsite manufacturing systems that do more than just improve productivity. They have a unique approach to industrialized construction, a lineup of flexible automation systems specifically designed for the construction industry, empowered by CAD to Fab, and turnkey solutions for 3D volumetric assembly, structural insulated panels, finished wall assemblies, MEP component processing, assembly, kitting, and storage. Learn more at thinkbrave.com. All right. Again, thank you to all of our sponsors. We cannot continue to bring you all these informative, informational conversations to all of you out there. So yeah, maybe it was a long weekend, but we're going to have a lot of fun today, and I can't wait to bring Karen on. So let's hop right into it. Karen, how are you?
Hey, I'm doing well. Thanks, Dave, and thanks to your sponsors so I can be on the show with you today.
Yeah, well, listen, they're very grateful to have you on the show, and we can't do this without them. And guess what? With most of them, you can't do your job either, so you need them as well. So this is amazing, amazing stuff. So on this show, Karen, we always start off pretty much the same way, and we say, we want to know everything about you from the moment you were born to this very moment in time. Don't leave out any of the good stuff from the hospital. Or I will go to West Virginia, and I will find your family. And I know in Morgantown, it can get pretty embarrassing. So maybe that's why you're in Texas now. We'll find out soon. Otherwise, you got 2 minutes. Go ahead.
All right. So 2 minutes from cradle to grave. Okay. So like Dave just said, I am from Morgantown, West Virginia. So grew up there. Once I finished my high school in West Virginia, I went to University of South Carolina, where I majored in chemical engineering. And coming out of that chemical engineering program, I had the opportunity to interview and hire on with a company called Baker Engineering and Risk Consultants. And it was a wonderful opportunity. So to give you a little bit of a background on Baker Risk, they are a unique process safety company in that they are associated with anything that can go wrong in industry. So they look at what does happen. So if there is an accident or an incident, they are the team that actually goes out and investigates that. But then they also do the predictive side of that. So what could go wrong, and in an industrial city, anywhere where there's hazardous, flammable, toxic, or explosive materials. And then there's the side where it's like, okay, well, what do we do to mitigate that and make people safer? So as a 22-year-old straight out of college, it was such a unique opportunity that I have since stayed there since. So I'm in my 17th year with Baker Risk as the parent company, and actually joined the subsidiary Fortress Protective Buildings about 2 years ago, and then full-time as president about a year ago. So really interested in the Fortress side of things, because as a process safety engineer, I was telling clients, hey, you've got a problem here. You have high risk. People aren't going to be safe, without really being able to tell them what to do about that. And now that we have Fortress, we can say, hey, here's a solution for you. You have blast hazards, this will be good for you. You have fire hazards, it'll be great, especially toxics, which is a different thing altogether. We have a robust toxic system, which I'll talk about a bit more. And all of that coming together for a package for the petrochemical world that we have now actually moved more into the residential and commercial space as well, which I can cover there. So that's me, 2 minutes. I hope I hit the 2-minute mark, but
perfect.
Well.
Hey, listen, we get to blow things up today. This is what's fun about it, right? We're gonna look at some blast videos. We're gonna get into the nitty gritty on all those fancy things you talked about chemical protection and what have you. And in today's environment, I think it's on a lot of people's top of mind, where this world is headed, or they have relatives overseas, whatever the case is. So with that said, you are the CEO of the company. And how long have you had that position now, Karen?
So I'm the president, and I've had that position since August of 2022. So just over 1 year. That company started it really got going in about 2020, which we all know was not the best time to launch a brand new company. So we're now hitting our stride, and we're really excited about what's coming up in 2024.
Yeah. So why don't you talk to us a little bit about where you are now? Where's your production facility at, and who are you shipping to, or like distance wise?
Right. So we have probably our main partner is Tyndall Corporation. They are one of the best precast concrete providers in the U.S. We work with their facility in South Carolina, which is their infrastructure division. And they actually are the ones that cast our modules. And I'll show you a video here in a second, and it'll show you what some of those behind the scenes looks like. It's that #1 video there. And that lays the groundwork for our actual product. And this is what makes us different. We can ship those into site, bolt them together on site. Takes about a day to do 6 modules. We can do anywhere from 200 square feet all the way up to 20,000 square feet we've quoted. So it's extremely flexible. And because it's already been designed and engineered, it's a very quick process. So that's where Tyndall comes in. We can ship anywhere in the continental United States at the moment. We have the ability to ship up into Canada, and we've recently been looking into international shipping opportunities because of a new product that we have, which I'm going to be happy to introduce to your group here a little bit later.
Excellent. I love it when you hear it first here on Dave Cooper Live.
That's correct.
And I know we're going to show some things, but when you say you can build up to 20,000 square feet, single level, multi-level, tell us what that means.
So in an industrial environment, it does need to be single level, at least in this point in time, because of the way our connections work. So we have a proprietary patented design in the way that we do our reinforced concrete modules. And we've not expanded that into that second floor space for residential and commercial applications. So let's say there's assets that you want to protect, or we have one client who has a gallery and very expensive collectibles that he wants to be able to showcase. In those applications, we can get to that second floor because his profile is going to be a little bit different in terms of hazards than what we're looking at in an industrial space. So use case drives how we recommend using our product. But again, it's all built out of these pre-module, prefabricated, reinforced concrete structures, which really helps us on quality control and schedule.
Sure. And, with this relationship also that you have with Baker's, with your company, Baker's Risk, Tyndall, are there any conflicts of interest?
Oh, that's a great question. I actually saw a competitor wrote an article about this earlier this week, so that question is spot on. I can say I was a consultant for Baker Risk for 16 years, and we do not recommend solutions unless it is the right solution for the client. And sometimes our building will be the right solution in high hazard areas where you can't move people away from the unit. So, for example, if an operator has to be the first line of defense, or you need to have your eyes on the facility, or maybe you're just landlocked in terms of what land you have to use, that's a fortress situation. But if you can move people away from the units, that's the golden rule. And Baker Risk is always going to recommend following the golden rule for process industries and tell folks, hey, you don't need a fortress. You have these other options, and those are likely less expensive. So, in my opinion, no, there's not a conflict of interest.
Yeah, perfect. Why don't we show this intro video? Can I play that first video so everybody can have a better understanding of who you are and what you're doing?
That would be great.
What makes the perfect blast-resistant building? Is it the technology, design flexibility? Maybe it's a quick installation, or the proven power to withstand extreme industrial hazards. Try all of the above. That's why your team deserves a fortress. Our turnkey structures go beyond blast resistance to protect your people from a wide range of hazards, keeping them safe and comfortable no matter what the day might bring. Get home safe. Get a fortress.
Oh, I love it. I love it.
Yeah. So that video highlights several important things about Fortress. So what you saw there was clips of the full-scale testing. One of the benefits of the parent company with Baker Risk is they actually have two full-scale testing facilities, one just east of San Antonio and one out in West Texas, where we can actually do some very large explosions. And I'll show you some of those here a little bit later in the day. But because of that, we've been able to not just design our building on paper and validate through computer codes that it will behave the way it's supposed to. We've actually full-scale tested that and pushed it beyond design capacity to make sure that we are covering that full range in terms of protection. And that is one thing that Baker Risk brings that most product companies don't have access to. So we're really fortunate in that respect. The other thing that you saw in that video is that modular design concept. So our modules, one is we call our modules, and they're 16 feet long by 10 feet wide by 10 feet high. And we can use those like Legos. So you just put them together to get the floor plan and space that you need. And then once you get that, it's just basically an open box, and you can do whatever you want inside in terms of fit out. We work with the architectural folks, work under us, and we design and lay it out exactly how you need. So you're getting the full turnkey product just from us.
How do you, when you put modules together, seal the seams and everything? Because I would imagine that's a very big concern since it's not a monolithic pour, right?
Right. So that's a great question. And those seals where those modules come together, that is actually part of our patented design. So we are as concerned about fire and gas ingress as we are of explosion. And those seals are specifically designed for fire protection and to prevent gas ingress. So it's actually a 3-layer seal. One layer is to protect against fire, one layer is to protect against gas ingress, and the other layer is to protect against direct impingement in terms of heat. So that's all on the outside. Then there's a seal on the inside, and all of those have been full-scale tested with our jet fires as well.
What is a jet fire? Do you like bring a jet, back it up to it, and like let it rip, or what?
So a jet fire, if you can imagine, is if you take a propane torch but on steroids. So instead of having a little hole, you've got a massive hole, and you just put it right up against a structure. That's what's considered a jet fire. So when you're in an industry where you have flammable gases or liquids, that's pretty much the highest heat profile you can get on a building surface. And so that's what we've tested against.
Right. And I'm going to tie this back in. Is this where the chemical engineering side of you comes in, to where you're kind of liking how the chemical side's playing with the protective building side?
Yeah, that's
in a lab, right, with a white coat on.
Well, that's a great question. So why a chemical engineer is in charge of a company that makes buildings, right? So The first 16 years I worked for Baker Risk, I was actually the one visiting these facilities all around the world, doing the analysis that says, hey, if something goes wrong, this is what's going to happen. If you have an explosion, you could impact people here. If you have a fire, here's your exposed populations, and really putting the risk profile into perspective as to how safe are people on these industrial facilities. And what I found in doing that, again, all types of industries, all types of companies globally, is that if you have more than one hazard types, it's extremely hard to mitigate that, especially with the building design. And so when internally to Baker Risk, when our group started working with our structures group who does building designs, and we came up with this design that takes all the benefits of reinforced concrete and puts those together into a multi-hazard resistant building. To me, this spoke to me. I mean, people talk about their one thing, and for me, my one thing is saving lives, and this product does that, and I'm very excited to be a part of that.
You know what? I think that's a really awesome and honorable one thing to have, because I asked that question, what's the one thing you'd leave with people, right? And I don't think anybody on the show, and we have over 2,000 interviews, nobody's ever said saving lives. That's super, super cool. So I appreciate that very, very much. With that said, modular construction, building codes. Well, I already know structurally you exceed any code out there, right? That any residential or commercial probably needs to do. But my guess is you still need to be certified. You still need to have somebody that looks at this. Who does that for you? Because we know who does it for our industry, with the third parties. Is it the same for you and the same people?
So it really depends. Now, when you're working in an industrial environment, it's all about your QA, QC processes and making sure that you document the product that you're giving the end user and end client. So we're keeping QA, QC associated with the parts of the building and safety features that we provide. And a lot of that is associated with the thermal and toxic protection. For the actual building structure, Tyndall, who's got the top level certifications for precast concrete, they're keeping their normal QA, QCs, which all goes to the end client. And then once the building is in place, depending on whether it's ADA compliant or not, different folks will come in, but the fire department comes in and looks at occupancy things. So that's kind of how the industrial setting works. When we start moving into providing storm shelters, which is one of our markets, then ultimately we have to start following the ICC 500 and FEMA codes to make sure we are providing all the different safety protections that are required via those mechanisms.
Got it. So in other words, you still have to follow all the different guidelines. So it sounds like a very similar process that the rest of our industry goes through. I'm going to put this up here just because I'm flashing through some of the things you sent me, right? What is this 2023 PCI Design Awards?
We are so excited about this one, and this falls right in line with what you do, Dave, with focusing on the cutting edge technology associated with construction. So we were the 2023 Precast Concrete Institute Design Award winner for the Harry Edwards Industry Achievement Award. And what's extremely important to us about this one, which is that it awards fresh, uninhibited concepts that hold the potential to change industry forever. And that's what you're trying to do with your technology. That's what we're trying to do in terms of safety. And this, to us, just spoke volumes.
Love it. There's another picture after this I want to show, and I know you have a 2-slide presentation as well we're going to go into. What are we looking at here? I see somebody pointing at the whole group of people, and it looks like they're all happy with him, so he's not running for his lives or going to jump in that building for protection, I'm assuming.
Right. So what you see here, that's Thomas Mander. He's our lead structural design engineer. So he's the brains behind the actual concrete structure. He's talking to a group of industry process safety professionals that came and did a tour of our test facility. This is our Lavernia test facility. In the background there in that metal building, you see what we call our shock tube. And with the shock tube, we can test any building specimens up to two stories in height. And so we've tested doors, windows, building systems, and for some governmental agencies, I can't talk much more about that, but a lot of work is being used on those specimens, which have actually been used to test our specimens as well. So behind him, you see what we call our specimen yard. And so the door that you see there that looks charred, well, it is charged. It was directly impinged with a jet fire for an hour. But then that door opened right up. On the back side, there's zero damage. You can see there's no damage to the concrete there. So that right there is showing all the audience that Thomas is talking to, just the robustness that our building provides. That wall that you see his hand in front of, that's a test specimen that's been hit with loads that are extremely high. So if for those of you in the audience that may know, this is above a 20-pound load, long duration, which is about 20 times plus any type of wind loads that you would traditionally look at. So extremely high blast resistance within that wall structure.
Very cool. Very cool. So, and how long has that building been there? Like how many times has that been tested? Or is that just a one-time test and then it moves on?
No, so those test specimens that you're looking at there, that wall where his hand's in front of, we tested that 7 times with 7 different pressures continuously increasing, and it's been there for 5 years since. The doors that we tested with jet fire just to make sure people would be safe on the other side, those still open. Those have been there for 5 years. So this is really just a showcase of all the testing program, and it highlights for folks when they see the videos of the testing, what those look like today.
Yeah, and I do like the testing. Now explain these tubes to me up here again. What do they actually do?
Yeah, so the part that you see is the expansion area, and we can stack different size expansions on so that we can get smaller specimens like doors or windows, or larger ones like full building systems. And those are connected to what we call a driver. And so we fill that driver with compressed gas, depending on the actual pressure regime or the load that we're trying to put on that. We'll use a different kind of gas to a different pressure. And then once we let that rip, it basically applies an explosion load to that door, window structure, and gives us an idea of how that's going to respond in a given event or blast.
Excellent. Excellent. And for those of you that are interested, we're going to show some more cool videos. We are. So just hang tight. We're going to show some more.
Yeah.
So, all right, this is awesome. My last question on this photo, it looks like there's no roof on there. Is there typically a roof on these as well?
So it's these are just panels. We're typically casting the full thing. So the roof, the walls, the floor, all cast at once, 8-inch thick reinforced concrete. The reason we do monolithic is it allows us to curve the rebar around the corners, which gives much more strength than having to have connections that you're then trying to bolt together at those points.
Awesome. All right. So I'm going to put up this 2-pager that you have here that you sent us. Is that all right?
Slide? Yeah, that's great.
Screen, and why don't you tell us what we're looking at here?
Okay. So I just wanted to walk you guys through a couple of photos. First, this is our first building that we built. This is at the Bakerist Test Facility. We call it our nameplate 1, but as all of you in construction know, you need a lessons learned building. This was our lessons learned building. We learned a lot. We did a lot of design revision. And because of that, once we actually hit projects in the field, we were able to do a really great job from the very first one. For whatever reason, it's not gonna let me step through those photos. That's interesting. Those are supposed to come up one at a time to show the construction process, but I will just talk to what's on the screen for you if that's helpful. So this building here on the right is one of our buildings that we've actually done in the field. There in the front, you'll see what we call our vestibule. It's a 10 by 10 by 10 module. These off to the side are 16 by 10s. Here it is from the side, so you can see there's 1, 2, 3, 4, 5, 6, 7, 8 of those stacked up. So like I was saying, you can use them as Lego blocks to get the square footage that you're looking for. Worth noting in this photo, it's a little bit harder to talk about than some of the other testing where we'll have our jet fire, our explosion testing, is that toxic protection. So you'll see here outside this door, which our door is also a proprietary design door that's good for blast, fire, fragment and gas ingress as well. Those gas detectors there are detecting for any potential flammable or toxic gases. If these detect something, we know at this stack that we need to shut down any type of air that we're bringing into the structure. So that means that the air inside remains safe so that the operators in there are able to bring the system to a safe state. Oh yeah, and
Just moving around. I don't know why.
Yeah, just move them around. So if you move them all to the right, we can step through them one at a time because it's kind of this construction sequence there. Yeah, there we go.
Perfect.
See, we can make technology work for us.
Yeah, I don't know why it did that. That's all right. Let's do it.
Okay, so what you see there is one of the pictures you just dragged over is the form. We can look at that one in a minute. But this is once we strip our modules out of the form, you asked what that looked like. You can see this is actually the roof. I know that because there's the lifting lugs there.
Right here.
To set it into place. You've got your wall, and then you've got your floor here, and then a column here which holds it all together and gives it its inherent strength. All of it, as you can tell, is very thick reinforced concrete. This is actually 8-inch thick with two different rebar meshes in there. And what this does, again, allows there not to be any weak points, but then allows us to put these modules together and bolt together at where you see these bolt connections. And each one of these weighs on the order of magnitude of about 60,000 pounds. So there's a lot of mass behind that. When you bring these together and start bolting them together, this built-in floor acts as a foundation. So in terms of what you need to do in terms of groundwork to support the building, it's not a lot. Building comes together and it sits on a slab. You grout in between the slab and the base of the building and you're good to go. So very straightforward process.
Very cool.
Yeah. So
if we slide this one over.
Yeah, we talked about that one a little bit. That's the building coming together.
What's going on here?
You can delete them as you yeah. So this is after our building has been coming together. This is looking down the hallway here. Worth pointing out in this photo, which is why it's included, is the holes that you see, the 2 square holes up at the top. I'm not sure if you can see my cursor or not, but those are actually where we put what's called a bubble tight damper. So what those do is if there is a toxic release and toxic gas is detected, those immediately shut. So anybody that's using the door to come into the building, that just eliminates a leak point within the HVAC ducts so that you're not cycling bad air into the area where people need good air to remain and be safe for a long period of time.
Got it.
Yeah. The picture in the front over there on the right, that just shows the gas detectors up close. The one with the green tip is detecting your flammable gases. The other 4 are toxic gases. I won't say which ones, but what we're monitoring is acute toxic. So if you get exposed to above a certain level, unfortunately, it would be immediate death. So that's what we want to make sure that anybody in these buildings are protected against, and this building does it. So it's a beautiful system that's designed by Baker Risk. So I have to give them all the kudos for it, but it works wonderfully. It's a touch screen. It's very user friendly, and we've gotten great feedback. Our longest buildings have been in the field for over a year, and nobody's had a single issue with these systems.
Okay. All right. Looks like we got some steel panels here, or some
framing. So you can see where those bolting points, both on the right and the left, these are where the modules come together. So bolts are torqued together, and you can see down through there, you've got one module in the front, then another module. So anywhere where you see the columns coming together shows the joining of modules. The daylight in the picture on the right-hand side that you see, those are our utility blockouts. So we will run all our utilities through there and then put an 8-inch thick reinforced concrete block that sits over that on the outside. A lot of people say, what's the purpose of that? Where your utilities come up from the slab and go into the building, if you were to have a blast or a fire, that becomes a weak point, and you don't want to lose power. You don't want to lose your fiber optics. That box that sits over that protects it to make sure that this building remains fully functional in an event. So the picture on the right, and I assume your audience is going to love the delivery in the crane system. So you see low buoy picture on the right. Each module comes in on a single low buoy. We've specifically designed those so that no special permitting is required. And then they line up in the order that they get placed. And then on the right, you can see that crane is placing it. So there's lifting lugs to make sure those get in place on the slab. We number it out, stage it out, it goes pretty smoothly. I said before, we can do about 6 of those in a day as needed in terms of getting them placed together. So that shell comes together extremely quickly.
What's the weight load on these when you're lifting?
About 60,000 pounds. The heaviest one is 66. The ones with only one wall, roof, and floor is somewhere in the 50s.
Got it. Perfect. What are we looking at here?
That's the formwork. So when we looked at the module back at the beginning, that's what it looks like from the form side. So it's basically from the top, you pour the concrete. It flows down to the sides, flows under to get what's on the bottom there. It cures, you strip the form away, and then you have the full module. So that's what the form looks like.
Excellent. And what are we looking at on the right here?
That is the completed building. So wow. See, it's an industrial setting there. That from beginning to end. So again, we do the engineering, the design, the architecture, the MEP, fabricate the modules, bring it in, and then put everything together on the inside, run all the gas detection, and all of that happens in less than a year, which is really, really quick for this type of protective building in an industrial setting.
What do these sit on? Is it just a big fat concrete slab, or is
So the slab tends to be 6 to 8 inches thick. We use shims to kind of level it. So we set the modules on shims, and then we grout between the slab and the building, and that's it. Yeah.
No kidding. Yeah. Excellent. So you can do about 6 of these a day and tie them together. What's your quality control like for the job site? Are you subbing out that slab work to like a concrete mason, or do you handle all of this? Because I would imagine hoping that somebody gets it right is just not an option.
No, that is crucial to make sure the slab is right, because our building is very heavy. We actually tend to have the owners do the slab because they have built-in contractors that they like to use that understand the geotech issues associated with their site. And so the site provides the slab, and then we do a visual kind of just checking to make sure that everything's where we need it to be for placement of our modules. And then we bring our modules in and put it on the slab.
Got it. Let's move in. We got some more videos to show here. I do believe these are going to work, right? So I'm going to do a screen share on this, and let's take a look at what we have here.
Yeah.
Is that we needed a little bit more mobile option as opposed from Fortress. The Fortress is a permanent structure.
There's so many use cases for Defender, both industrial and non-industrial. So you've got storm shelters for tornadoes and hurricanes, potential safe rooms for residences. It's a great option for data centers, so critical equipment protection. Just like the original Fortress, the Defender does protect against blast, but not just blast, also toxic flammable gas ingress, fire protection, fragment protection, and extreme weather. Get a Fortress today because it is the next generation of protection.
I can't help but giggle every time I see something hit that wall or explode. Just being an ex-military guy, I'm like, that's awesome, because we all hope to always have something like that around.
Yeah, I got some close-ups of the explosion for you here in a bit too, and I'll talk a little bit about structural response when we show those videos. But that video there, that was actually the launch video for our new product, which is Fortress Defender. And we're super excited about that for a couple of different reasons. First of all, going back to our bread and butter, which is the industrial facilities, there is a need for portable buildings for turnaround construction, bringing in maintenance crews. They need to be closer into the facility, so they need to be protected. We did not, up until launching the Defender, have a Fortress option that was portable. So very excited to offer this. It's a little bit different than the larger Fortress building in that it's only 6-inch thick reinforced concrete, so it's not quite as robust, but it still provides that multi-hazard protection of blast, fire, fragment, toxic gas, and extreme weather. So in that video, you saw a range of different tests there. We did 2 different types of explosion tests. One, which is from our deflagration load generator, which is more of your traditional gas vapor cloud explosions. And I'll talk about that on one of the videos. Then we did your bomb explosion, which is your high explosive, and that behaves slightly differently. And I'll talk about that one too. But you also saw in there that we were doing the tornado and hurricane debris projectile hazards. Right. And that's because this is the ideal solution for storm shelters. It adds that protective capability, right, whether you're buying for residential purposes or for a neighborhood place to gather. This building is that solution in that it's lighter, it's less expensive. We can fully fit it out before we deliver it to whatever specifications you need. And I mentioned having to design 2 ICC 500 and FEMA previously, and that has been done here. So really excited to offer this, especially in light of many of the natural hazard events that we have seen.
You know, people that live in the Midwest, in the South, along the Panhandle, we traveled the country for 2 years in a motorhome, and that is not where you want to be when they start blasting tornado sirens and everything else. And, these types of, shelters, there's not enough of them close by is one of the things. So having that portability to put things in places that may not have an area for the full infrastructure of something to be built or something that could be temporary, I think is pretty darn awesome. So yeah, firsthand, I got videos I'll have to show you where I'm sitting in the motorhome going and talking into my, everybody's like, "You're recording this?" I'm like, "What else am I going to do?"
Yeah, and the secondary part of that is that in some of these areas where there's natural hazards, so whether it's wildfires, tornadoes, hurricanes, but then also some in remote locations where there might be exposures to security threats, mission critical buildings associated with telephone infrastructure, data centers, these remote edge data centers that are a bit smaller. This building is perfect for that because it handles all of the natural hazards and the security threat issues. And so we've been talking to some of the folks in those industries as well. And this adds a little bit different robustness than the standard steel metal buildings that you'll see in those industries. So excited to bring another option to provide that protection to make sure that for mission critical things, it stays online and is there when we need it.
Oh, here we got another video. Shall we add it to the screen?
Yeah, which one is this? Oh, this one's a good one. Okay, so let me give you some context here. All right, so what you see on the left is Baker Risk deflagration load generator, and it can simulate vapor cloud explosions. So if you think about industrial events, we all see these explosions on the news all the time. This box allows us to understand how structures respond without it happening out in the field. So you'll see the explosion come from there, and we're looking at 2 different specimens. One is our Fortress Defender, which you can see there at the bottom, which is 18 feet long, 12 feet wide, and 10 feet high. And then next to it is a traditional blast resistant steel metal building. So whether we're in an industrial setting or if we're talking about data centers, this is typically what you would call a protective building. As this plays through, you're going to see what happens inside on the metal building up top, the Defender on the bottom, and then it'll zoom in and show you both of those again. And I'll tell you what that means for protection after the video is over.
All right, let's do it.
All right. So we didn't even spill our Gatorade for that.
There you go.
Yeah,
That's important.
that's important. Um, so it was really funny. Our test manager for Baker Risk had his son out there, and his son went and put his name tag on that mannequin in the Defender. So that was our hunter mannequin in that case. Um, so what were we doing in that series of videos is we were trying to highlight for industry the difference between building response and actual vulnerability inside that building, whether that be to a person or to critical equipment. So you'll see that the metal building slides over 7.5 feet on the inside side. What that sliding does is that creates what we call internal debris hazards. And you will see that stuff kind of flies around everywhere. In addition to that, the reflected wall steel is designed to flex. And with that flex, you can see that it causes a bend in that front wall and things start moving. Other tests done by Baker Risk and those shock tubes that you saw in that big warehouse earlier has shown that those move at G forces upwards to the 80 to 100 range at design loads. Anytime when you're moving that quickly, you're damaging any type of electrical equipment. So when you're talking about mission critical and data centers, you do not want any type of security threat to hit those buildings because nothing inside is going to work after that. From a vulnerability to occupants standpoint, you can see everything in there is just flying and becoming projectiles depending on the size. If you get hit in the head and the chest, you're going to have some severe injuries. What we've done is designed a building where you get none of that movement on the inside at design loads.
Well, you know, and a lot of people, just from my experience, when you have incoming rounds and explosions, right, it's the percussion that gets you. I always tell people, remember, you know, when you're young and younger than me anyhow, and you used to hang out in the club and you stand in front of the big bass speakers, right? And you can just feel your whole body vibrate. It's like that, but 1,000 times harder and higher, right? And that's what causes that what do they call it? Precussion?
Yeah, that's like the force of the blast on your body. Yeah.
Yeah.
Yeah. And so you didn't even hear the blast in that building. So that's kind of the industrial setting. The other video that you've got there is more for the security setting, and it's equivalent. It's ANFO, which is ammonium nitrate fuel oil, which is a bomb, and it's the amount that's equivalent to 1,000 pounds of TNT. So everybody, TNT is dynamite. So this one's a little bit more relatable to most folks.
I would have played a little bit of AC/DC when you said that. TNT.
Dynamite.
You're feeling me, right?
Yeah, I'm feeling it.
Let's see what we got here.
So you can actually see the percussive wave come off of it.
Right. That's what I was trying to say. Percussive.
Yeah.
That'll lift you off the ground, that wave.
Right. And so you can see that you can hear it inside, but none of the books even came out of the bookshelf, which one of them had a $20 bill in there as a bet to what could happen. You can see somebody won that one because it didn't move.
Yeah.
So it slid about 1/4 of an inch in terms of movement. So because of the weight, it just didn't move. And that's the type of building when you're talking about mission critical facilities, you want your equipment in there because you saw the lack of movement. It's going to continue to operate.
Yeah, it is. I would imagine, like, you know, sensitive data centers would want this.
Correct.
Right? I would imagine, like, when you look at the Googles and the Amazons of the world, you know, and depending on the part of the world that they're servicing, I would imagine this would be a huge data source for, you know, infrastructure.
That is correct, especially if you think about back a couple of months to some of these incidents that we saw at power stations down around North Carolina areas. This type of structure eliminates the worry for that.
Sure. Let me go on to the next here, what we have.
Yeah, and this one's the one that we're gonna have that same issue about not being able to see the slides.
Let me see if I do it a little differently. Maybe it'll work here. But
Yeah,
you can go ahead and talk about it here.
right.
We're going to look at, and I'll see if I can get this to play through.
Okay, so if nothing else, we can look at that second slide. That first slide there on the fabrication is just showing you, it's stepping you through the fabrication process, and it really does show you how we're using a single form. We tie the rebar around the form, bring the formwork in, pour the concrete, and it strips out as one piece, and then we set it on the floor. There's basically points where we weld, there's embeds where we weld the top to the floor, and then you get your single module with lifting points. So whole process, very straightforward, single pour, 4 lifting lugs on top can be moved around from there forward. It's cast with the door in mind. Dean Steel manufactures our doors. We just bring them in and weld them in, and the building's done from a structural outside perspective. If you move to the second slide in that presentation, though,
I'm going to try and make this right.
okay.
Let's see. There we go. I think I got it. Let me pull it up on the screen now.
Right. Okay, great. All right. Yeah. Okay. So I have to blur the rebar because that's patented. So, but you can see the rebar is tied around basically a steel block.
Yeah.
And on the left-hand side, it's like an L shape, and the back and the side is pulling in next to that rebar. And the back and then the front, you can see it's pulling in, and those are tied together. And then if you go to the next one, concrete just flows down around it, strip the formwork off, and you've got your concrete block. They've tied down into the 4 lifting points. And then the next one. And then the next one, you can see it just kind of strips up off.
Wow,
yeah. One single piece.
So you're lifting it off. That's really cool. Okay.
Right. So
like olive oil on it so it slides, or
yeah. I don't know what they do, but they do an amazing job at Tyndall. Then there you've got your box, and then the next one's of the floor. And you can see where the little lighter colors are. Those are where the embeds go. And then you just weld the top to the bottom. And the next one shows the completed one on a truck.
Wow. Yep.
So very straightforward process. I did want to take a minute to talk about this one, though. This is actually our Baker Risk and Fortress teams. I did not put any pictures of me on here, so that's good.
You're on the whole show, so you're there.
Yeah, exactly. So crane comes out, lifts it from those same 4 lifting lugs. We've got 2 side by side. The one on the right's actually used as a data center, so you can see there's a raised floor there. The one on the left is more for a construction trailer, so it's actually got 2 doors for safety and escape. The reason why we decided to fit this out ourselves is so that both the Baker Risk teams who are designing this and the Fortress teams who are making sure they're built properly out in the field understand how important every single detail within the design is. So we showed that video earlier where internal debris was thrown in the blast. We are able to limit that by making sure our stud work inside is separated off of the wall by the amount that we're predicted to deflect in a design basis load. So we're never actually putting pressure on that wall in the same way that other building construction types are, which limits the movement, which you saw in that test. So we cut every piece of steel, put it all in, drilled every hole through 6 inches of concrete, and finally got the data center that you saw tested in those videos. So yeah, it was a pretty exciting process and great team building.
Yeah, very cool. So, I mean, just other applications as I'm thinking about this, would you build these inside like somebody's building a bigger building? Can you put this inside another building just to protect inside the building as well? And they would build around it? Is that kind of the idea here?
That is one application for it. So there is a lot of different manufacturing industries which will have basically a big prefab metal building, and then they'll be doing some sort of a reaction or or heating something up, or even testing things that might become projectiles, they'll put one of these buildings inside to protect their workers from that. Another application, if we think more into our daily lives, is a safe room from a residential perspective. So some of the smaller modules embedded within a larger structure to go into to provide protection. It's basically impenetrable, and you have the extra protection from not getting smoke, gas, anything like that internal to that structure. So because we're bringing the structural design with the process safety and control systems associated with the construction know-how, we can really design and tailor the product for the specific needs of the buyer. Oh, I've lost you. I've lost you on my sound again over here.
Oh, there you go. So I got
There you go.
photos here I want to put up. So
Yeah.
this is the team.
That's the testing team. So you can see that box behind that I said we fill with gas and apply a vapor cloud load. That's the Baker Risk testing team, marketing team, and our Fortress team. And you can see little Hunter there in the red shirt. He was the one that was rooting for his mannequin in the Fortress building.
I mean, how awesome is that? Just addicted now, I'm sure of it.
Oh, yes. And it's amazing to go out there and see all the hard work that goes into these levels of testing. And then if you want to contact us, here's our Fortress team. Not everybody was present for this photo, but you've got me, our CEOs there on the left, Bill Mather, and then you've got Brian Royo and Alex Soto in the middle as our project managers. And then Tim Host on the right-hand side does our business development. So reach out to us at any time via our website, or there's our contact email there at the bottom, and we would be happy to help you and tailor our solution to give you what you need.
Well, we got a couple comments I definitely want to get to here as well, and thank people. But before I do that, is there anything that we didn't discuss that we need to discuss? Did I miss anything?
No, you didn't miss anything. That was a pretty good overview. I do just want to come back and say that this really is for us the culmination of 40 years of experience with Baker Risk and trying to protect people. So overall, the big driving goal for us is we want to make sure that people are safe and go home every day. And that's what we're doing. And we're very happy to be doing that.
Well, we're happy to have you here doing it for our audience as well. That way, we got a lot of people that are consultants working with big corporations, and this is just another tool in your tool belt for whatever you need. And then I also know some of you are working with the government out there, because I just had a whole conversation on a building a CIA is doing, and air tightness and smaller holes. And so you know what I'm talking about. It wasn't you, though.
Yeah.
But that's the world you play in as well.
Right. The parent company has done a lot of work for government. Actually, that was kind of why we were founded back 40 years ago. So a lot of those thought processes are behind this design.
Love it. All right, Greg Ugaldi, the past chair of the National Association of Home Builders. Good to see you. Great presentation with Karen today. Always a pleasure when you join us, Greg. Greg is the guy that updates the President of the United States and the Secretary of Housing when he was doing his rounds in Washington, D.C. So it's always great to have people with that insight and that view to share your knowledge, because he does play at a very high level in the government. So good. Thanks for joining, Greg, by the way.
Thank you, Greg.
Yeah, Peter Molinar, question: could the Fortress structures be built to meet the passive house standards? So in other words, could they be built energy efficient, low carbon? Are you looking at different, this is actually a really good question, right? Because there's the, what Peter's talking about, like on the passive house standards, energy efficiency, how do we reduce carbon, become carbon neutral? This is full of steel and concrete. So where are you headed with it?
Yeah, that is a great question. So first I'll start with concrete the thermal mass of concrete is inherently protective from a thermal and heat perspective. It's one of the reasons why it's great for protecting against fires. That also means that when you're talking about being very hot or very cold inside, the inside temperature retains very, very well. So when you're talking about energy needed to maintain temperature, it's much lower in concrete. And that's why we see a lot of concrete construction in areas of the world where extreme heat is an issue. So concrete does have that going for it. There are concrete mixtures out there now that are actually designed to be carbon sinks. So actually pull carbon and carbon dioxide out of the environment to store within the concrete structure. We have looked at that, and Tyndall's actually running some of those lines across different ones of their facilities, one in Virginia, one in Atlanta, and they're looking at putting it in where we are. So as the industry starts moving more towards that, that's certainly open for us. The steel, the reinforcement issue, if we start moving towards housing, we'll need less of the reinforcement than our current design has, which takes some of that carbon from steel, but then also hopefully decarbonization associated with hydrogen. And those hard to abate industries will help as well. So we have been thinking about it. We have a list of different things we can start to implement as needed and depending on the client requirements in terms of carbon. Sound? Missing your sound again.
I don't know why it automatically muting me here. So I wouldn't expect that type of, question typically. I think it's a great question because even at the very highest levels of protection, you're still focused on how you can do it better, environmentally friendlier, all of those things, because these buildings are 100% meant to last. And the most sustainable buildings out there are the ones you don't have to rebuild.
That is correct. If you look at it, the structures built during World War I, World War II are all reinforced concrete, and they're all still standing today.
Yeah, sure. All right, we got our friend Henry Mickelberg out there. One thing I learned was that the concrete ain't the problem. It's the doors and the windows that will let you down. How does Fortress navigate the mixture of design codes, FEMA, UFC, ACI? I'd like to think that things are better harmonized since my same force protection days.
That is a great question. I did not load any of it, but if you go on our website, you can see some of it. We actually have a window product that we've been working with and testing since about 2017, and we've helped them refine their design. We can get the same level of blast and fire and fragment protection out of that window as we do out of our main structure, which is very, very high. In terms of doors, that's a proprietary door on our main Fortress. It's designed to the utmost specs. No other door that I've seen has been designed to be that robust. The yellow doors that you saw in the little Defender storm shelter buildings, those actually did pass the ICC 500 and FEMA test requirements from a debris impact standpoint. And it also passed the blast test too. So because we are working with some of these companies that have experience, but then using our Baker Risk structural design experience to make tweaks to that, we're able to get the design specifications that we need out of those products. And those are fully tested too, and you can see those videos online.
Excellent. And I know we've been sharing where to find your information online as well. Jennifer says, all right, I'm uncomfortable with the thought of buildings like these in the hands of those who may not have a shared vision of safe. Do you do background checks on your clients, or can anyone purchase one of these? Great question.
That is a great question, and I am going to have to take note of that to make that part of our standard process. To date, most of our clients have been, or all of our clients have been larger corporations. So inherent in that is a little bit of safety from the background perspective. But now that we have a product that is perfect for residential and commercial applications, that's something we need to do, Jennifer, and I appreciate you bringing that to my attention.
Yeah, I appreciate that. All right, so I'm going to play this video one last time because I want to giggle. And with that, after we watch it, Karen, if you have anything else you want to say when it's over, just give us a holler. Other than that, we're gonna wrap this up. So here we go, everybody. Enjoy. Did not spill the Gatorade.
Mm-mm. So with that, I have two things to say. One is, well, Bakerist nicely tests our products. They are available to test a range of different products as well. So if any of your audience out there has products that they'd like to know how they respond to certain events, reach out to us and we can get you in touch with the Bakerist testing team. And then the other thing I would like to say is, after seeing all of that, which building would you rather be in?
Yeah. Yeah. Are you asking me that?
Yeah.
Well, I want to definitely be in the yellow door building for sure.
Yeah. Good choice.
Yeah, that's where I want to be. And if I ever get that job as a future war correspondent, I will be calling you to help deliver something to me. I'm over there.
We'll donate one to the cause for you, Dave.
I love it. Perfect. Well, Karen, thank you so much for coming on the show today. Thanks for sharing this. This is a first for the Dave Cooper Live show to talk about modular and the protective industry world. I mean, we've talked about data centers and electrical centers before, but nothing to this level. And I think it's really pertinent. And I commend you for what you're doing. I commend you for your position that you hold there. And you're bringing so much experience to this, and I think it's just a whole nother way of thinking. So thank you.
Thank you for having me. I really enjoyed it, Dave, and I appreciate your sponsors for making it happen.
Yeah, thanks, everybody. So that's a wrap. We'll see you this Wednesday. In the meantime, check out these sponsors as well, because of them, we can bring you all these awesome, informative conversations. Karen, don't go anywhere. I'll come back to you after the end. Bye now.
Okay. Bye.
What an amazing show. Thank you to all of our sponsors for helping us to continue to bring all of these innovative conversations to all of you out there. Please visit them, see what they have to offer you. And as always, subscribe to the YouTube channel and ring that bell. It would mean the world to us. I'm Dave Cooper. Thanks for watching.